Okay, today is stretches and shrinks part C. This is the hardest type of stretching and shrinking problem, and it's where the thing has already been stretched, and then you have to go back and figure out how it was stretched. So the equation, don't forget the y equals. You have to have a y equals or you're going to lose some credit. The minimum we mark off on tests is 5%. So like you're going to lose a bunch of points just for not having y equals if you forget that. Now, do you agree that this generally is an absolute value equation? So therefore it has an absolute value of x like this. Okay, so I'm started writing my equation. Would you agree it seems like it has been moved to the right? So then I therefore put a minus in there for the right. And how far does it move to the right? 4. All right, it's been moved 4 to the right. Now, the stretch part. I want you to try to look and see where is it supposed to have its dots. Those black dots is where it's supposed to be, as opposed to where does it actually have its dots. I'm going to put the green dots where it actually has the dots. You get what I'm trying to say? On a normal V shape, it should be where those black dots are, and it should look kind of like this. And it should be like wider than it is now. Hold on. Okay, there we go. So, do you get that this is an up-down kind of change? And therefore a vertical change? The black dots compared to the green dots? All right, so it's a vertical stretch. And should I say it's a stretch up 1? There is no such thing as a stretch up 1. A stretch factor 1? No. Stretch factor 1 would be like multiplying by a 1 in front. It doesn't do anything. It's a stretch factor. You're right about that. Stretch factor 2. So I put the 2 right in here. And now I've got my stretch figured out. Now, again, I know your instinct a lot of times is, yep, done with that one, move on, because I got a lot of work to do. If you really want to get these right, you've got to go back and check your XY chart. Do you get that this is now an equation which can then tell you some points on an XY chart? And if it tells me points that are actually on the line, then I'm probably doing it right. So now, do you think I want to put in x's that are really small or negative? No, I don't have anything over there. So I should probably put in x's that are like medium size, just like maybe 4. So stick in a 4. You stick a 4 right in there. Do you see how you go 4 minus 4 is 0. Absolute value of 0 is 0. 0 times 2 is 0. 4 comma 0 should be on my graph. Does 1 point by itself, once you put that in its backpack, that way you won't have any chance of hurting it. 4, 0 by itself cannot prove to me that I'm doing this right. I should put in 1 more point and make sure I do it right. So let's stick in like what? 1? I can do 1, but that's over here. Oh, it's actually over. My alignment's off. I can't hit the 1. Anyway, that would work. It's not that it's wrong. Let's do it. Let's stick in 1. If I put in a 1 right here, a 1 minus 4 will give me negative 3. Absolute value of negative 3 is 3. 3 times 2 is 6. So 1 comma 6. Over 1 up 1, 2, 3, 4, 5. Oh, look at that. It hits perfectly right there. I couldn't hit it perfectly because my alignment's off. But anyway, there. Now that I got a couple points to match, I think my equation is right. Do you get how if I would have thought this was a 1/2 out here by accident, then my points wouldn't have been lining up? That's how you can check and make sure you did it right. Yes? Are you required to check and make sure you're right? No. Well, you think it'd be smart to make sure you're right? Do you think it'd be smart to do? Yes, it would. Okay, good. The key is when you are taking your tests, see, you're practicing right now. If you practice and you never check when you practice, you're going to forget to check on your test too. And you're going to get, oh, I think I got it right, and then you're going to move on. And then you'll make some dumb little mistake like you think plus instead of minus 4. Whole thing's wrong. And if you would have just checked a couple points on the XY chart, you won't make the mistake. Yes? Yep, because where should this V shape go? It should be going over 1 and up 1. Gotta move that in position. And then it should be moving over 1 and up 1. And then if you look where it actually goes, it's actually going twice as high as that. Do you see where it's actually touching? See, this is where it should be. Why don't you draw the V shape from that little spot where it should be normally for a normal V shape. And then you ask yourself, where are the dots? Oh, they're higher than they normally should be. They're twice as high as they normally should be. So this spot right here is twice as high as it should be, and therefore, that's why I used a 2 right there. Okay, let's look at the next one. Oh wait, I should have said family. This is the absolute value family. And this one, what family is that? Square root. And the description, well, that is a square root that's been moved left. And it looks like it has also been stretched somehow. Vertical stretch. Factor, well, let's see. Do you get it should be going over 1 and up 1? Why don't you draw the parent in right there and see where it should be going? You go over 4, up 2. So if you compare this with the red one, which is the parent one, over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. That's the parent one. Look where it actually is. Is it twice as high as it normally should be? No, it's more than twice as high. 3 times as high. So you write your equation accordingly. And forget it was moved left 2 spots. I guess I never filled in these descriptions either. This one was right 4, and it was 2 vertical stretch of 2. My alignment's so off, I'm not even going to try to write that in. All right. That's the hardest kind. They've given you something that's been stretched, and you have to try to write the equation for it. I got to leave you some of those to practice. Let's go on to number 5. Everybody find this one. Y equals absolute value of x. Shrunk vertically by a factor of 1/4 and moved up 4 and right 6. I would recommend you write the equation for it. Absolute value of x, and then do the stuff it said. Vertical shrink factor of 1/4, up 4, right 6. Everybody write what you think the equation for that. Okay, vertical shrink by a factor of 1/4. Vertical on the outside, high vo, right? And why am I using the 1/4 instead of changing it to a 4? Because I can trust the stuff that's on the outside. And vertical's on the outside. So up 4 plus 4, right 6 minus 6 on the inside. Raise your hand if you had the same thing as I did. Okay, good. Then domain and range. Well, I guess I need the graph first. Once I have the graph, it'll be much easier. So if on the graph you want to graph the parent, which is a V shape, and then do all of those things to it, you could. I always say to start on the inside, so x minus 6 means right 6, and then I got to go up 4, and then I got to make it a stretch of 1/4, which means 1/4 as tall. So things that from here to here are 4 tall, you shrink down to only being 1 tall, so it'll look something like that. Very squished. Now that's just a ballpark though, so how do I get my exact points? XY chart. So I know it kind of generally looks like that. XY chart will tell me exactly where some points are. Like, always try to make the thing on the inside really small. Okay? Like 0. What could I put in for x that would make the whole thing 0? -6. So I stick in x is -6. And then negative, well no, it's an x minus 6 in there. So I don't want x to be -6. +6. So if I have +6 goes right in there, I have 6 minus 6 makes 0. 1/4 of that is still 0 plus 4 is 4. 6 comma 4. Now note, if I move over 1, 2, 3, 4, 5, 6 and up 1, 2, 3. Oh, I was off. it's got to be 6, 4. My vertex or my point, oh wait, my blue one does have a spot there. Forget that. I guess I'm okay. Now I better check another point though, because I might still be off. What's another point that's close to that? Okay, I'll put in 8. If I put in x is 8. 8 minus 6 is 2. 1/4 of 2. 1/4 of 2 is 2/4, also known as a half. Plus 4 is 4.5. Or 4.5. So 8 comma 4.5. 1, 2, 3, 4, 5, 6, 7, 8 comma 1, 2, 3, 4.5. Ooh, I was off. There. That's 2 points that are supposed to be on my graph. So my little really quick sketch wasn't very accurate. I got 2 black points that say differently. So I'm going to try another one. Let's say I put in 10. 10 goes right in here. 10 minus 6 is 4. 1/4 of 4, that works out nice, is 1. 1 plus 4 is 5. 10 comma 5. Over 10, up 1, 2, 3, 4, 5 is right. Alignment's off, sorry, right there. So I can tell that the right side of my V looks kind of like those 3 black dots in a row. Okay. So these were off, and that's what I'm trying to tell you is you got to be really careful as you're graphing with sketches and moving things around. You can often get off by like an inch or a box. When I do my points on my XY chart, it really helps me keep track. Okay, any questions about XY charts or making the equations or yes sir? Okay. So when it says y equals 1/4 x minus 6, absolute values, plus 4, do you mean when you're sticking the numbers into the equation, or do you mean like when you're actually, okay, all right. So if I have a graph, let's say I had a parabola, and I was supposed to do this to it, then it would be this squared. Okay. What you're supposed to do is take all the heights of the dots, like that's a height. And how high is it? That's a height of 2. How high is that? That's a height of 2. And I want to take the heights and I make them 1/4 as high. Remember, that's vertical. So the vertical number, whatever this is telling you what to multiply your heights by. So if I put a 2 out there, it's the easiest, of course. Now I would take all my heights of my points and make them twice as high. But if it's a fraction like 1/4, you make it 1/4 as high. So you just multiply whatever your height is. Heights are like the y values. You multiply them by this number. Or if it's a big number like this, you multiply them by that number. So that's what you multiply your y's by. Okay, so today is mostly meant to be a day where you have a lot of time to work and try to figure out how to do these problems on your own with some paper. You can work with a kid next to you, etc. I heard to wait. Do you have a last question? Okay, so you can have a bunch of time to work. I do feel like the assignment's a little bit long, so I'll tell you which ones I think maybe we can live without on this assignment. That's all I have for you for today.